Hello, this is Yulin. We would like to investigate whether it is necessary to perform online IMU intrinsic calibration. These days, visual-inertial navigation system has been widely used in 6D pose tracking for mobile robots. Online calibration of camera extrinsics, intrinsics, and time offset is used to improve the system performance. However, there is limited investigation of IMU intrinsics. Naturally comes the question, does online IMU intrinsic calibration also improve performance? To answer that, we would first investigate IMU intrinsic observability and see whether are there any degenerate motions. The IMU contains three frames: the IMU frame, the gyro frame, and the accelerometer frame. We define that the IMU frame depends either on gyro frame or accelerometer frame. The IMU intrinsic model represents the raw reading corrections. For example, these are raw gyro readings. The DW represents the skew and screw correction for the gyro frames. By choosing which parameters for calibration, we can define four IMU model variants. Each contains 15 degrees of freedom. We use IMU2 for example. It contains DW6, DWA6, and the rotation from A to I. The D matrix contains two parts. The diagonal represents the skew correction. The up triangular represents the skew correction. The system state contains IMU intrinsics and features. The system ODE is based on the IMU evolution model. The system measurements is based on visual feature UV pixel coordinates. By computing state transition and the measurement Jacobins, we can build an observability matrix. Carefully investigating the structure of observability matrix, we conclude that, given fully excited motions, even with monocular camera, IMU intrinsic parameters will be observable. However, we also identify 6 motions that can cause certain parameters unobservable. We call them degenerate motions. We want to emphasize that any combination of these degenerate motions is still degenerate. For example, y-axis rotation, which is common for maps, constant acceleration along x-axis, and planar motion, which are common for ground vehicles. These are all degenerate for IMU intrinsic calibration. We first verify our analysis with simulations. We first run fully excited motions with full calibrations. All parameters converge. The plots show the IMU intrinsic parameters convergence. All three cell bounds and errors decrease towards zeros. We also simulate 2 degenerate motions. The first is one-axis rotation, in which DW1 to DW3 are unobservable. You can see that the 3 second bounds and estimate errors do not converge at all. Similar for the constant AX case. Finally, we evaluate our system with real-world datasets. First is Team VI datasets. In Team VI, the sensor is fully excited, and you can see that the system performance is improved with online IMU intrinsic calibrations. However, on cast, in which the cars is running approximately planar motions, the VIO plus online IMU intrinsic calibration hurts the performance. Finally, we come back to the question we posed before. Is it necessary to perform online IMU intrinsic calibration? Our answer is, we recommend for fully excited motions, but we do not recommend for under-activated motions. Throughout the paper, we did observability and degenerate motion analysis for IMU intrinsic calibration with extensive evaluations. In the future, we will investigate full-width calibration analysis. Thanks.